Oh, welcome to Insights 135. So we're going to be talking about gRPC with Aleš Justin. But before we start, we can have a little bit of news. Although having said we'll have a little bit of news, actually, I don't think there is very much news at all. The Quarkus team have been at a bunch of conferences, but I think that's winding up, and a lot of the team are heading off into their summer holidays. And we've just released Quarkus 3.2.2, but we do micro releases so often that it's not really very newsworthy that we've done a micro release. So I think we can just get straight into talking about gRPC. So is this, speaking of conferences, is this something, I think, did you show this at Riviera Dev, Aleš?
Yeah, I mean, I had some intro as well into Quarkus because not many people, I mean, they are into Quarkus, but not many users. So it's like a combination of the two. It was quite new. So I still wanted to share some introduction to Quarkus itself so they know how at least a bit of the magic comes in. But I guess since this is Quarkus Insights, people probably already know how the magic is. More of the gRPC magic details that they are real into today.
Yeah, cool. How was Riviera Dev?
Oh, nice. I mean, it's always nice to be at the Côte d'Azur, right? Lots of people, as always, Steph and his co-workers. I mean, the co-organizers are really, they really make it special. And being the French Riviera, the food is, as you can expect, good as always. At least, I'm into beer person, so beer is expensive, wine is not.
Oh!
Yeah, it was really nice. So yeah, thanks to the Riviera Dev organizers again.
Did you have, because there was the photos that went around on social media a few years ago of during the pandemic when they had the little paddle boats. Did they have the paddle boats this year?
No. I mean,
No.
the thing is, okay, as I don't speak and understand French, there's lots of French talks, which probably doesn't make sense for me to attend. So there was I was always I was attending the English-speaking ones, which weren't as many this year, I guess. They had some late cancellations, unfortunately.
That's a shame.
The French people had to step in, like the ones that are close by, so they quickly step in. But yeah, otherwise, I mean, I did attend like a couple of them. It was still nice, and the place is nice. It's like a business school next to the hotel. Yeah, nice.
Yeah, sounds very nice. Yeah, it's one I haven't been to, and I had such a busy spring, busy summer, that I didn't go this year. But I think maybe next year I should prioritize it because I definitely do like wine, so it could work out well.
Yeah. Good.
So I think let's talk about gRPC. So I guess you've got have you got slides and a demo, or?
Yeah, I have some slides. We'll just probably quickly go over. I mean, I'll try to explain as much as possible what and how we do it in Quarkus. Even like a bit of introduction to gRPC. I guess probably people do know it if they're here, but for those who don't, it will be a useful exercise to learn a bit or two about gRPC. It's okay. Cool. I mean, it's a useful alternative to HTTP, right? If you need it for something, being like the microservices thingy, right? It's still like a easy and good way to connect the two services to microservices or more of them. And what is also like good is that it has streaming, so you can either stream into it and stream from the service, which is also like a useful feature in these days, right? We're streaming right now, so it could be gRPC running in the back, you never know, right?
Yeah, I always feel a bit guilty about gRPC because one of the things I do is I work on the Quarkus extension for Pact, and Pact can now support gRPC. And Quarkus can support gRPC, so it makes sense that we should have some test coverage for it. And so I need to add those integration tests, and I just haven't done it yet. And so on my to-do list.
I mean, I don't know how. I actually Most of the people that I talk to, they just go HTTP between the services, right? Because it's like really easy, and with I don't know, with the micro profile, it gets even easier. Just I don't know, annotate your interface, and you get a client, and you get and service out of the box. And previously, didn't have this experience with gRPC, but Quarkus made a difference in that way.
Cool.
And pretty much, we have the same experience as with REST clients and services, so just annotations and interfaces. And it could probably even go even further. We will see what the future holds, right? With some of the specs. At least the ideas behind the specs, or how things could even be even further improved.
Yeah, oh, that's really nice. I'm looking forward to seeing the demo.
Yeah.
Shall we show your slides?
The demo is going to be a bit more. It won't be the basic one, as I'll explain later. It's like an additional gRPC is not just. It is communication between the services and client service and so on. But they've added a bunch of new things, which I didn't even know when I started off with gRPC. But then slowly they were adding a new kind of types of servers, or types of features, like improved testing, ease of lookup and failover, and service discovery, and so on. And this is a bit that I'll talk about it as well. So.
Yeah. Oh, cool. Yeah, I think that makes sense. Yeah, because we've got hardcore advanced users on Quarkus Insights. We're gonna show the tough stuff.
Then start off with the slides, and you can just interrupt in between if you have any questions.
Cool. Yeah.
Glad to answer them.
Cool. So let's have a look at these slides.
Yeah, okay. That's just the intro. So, for those not familiar with the gRPC,
oh, can you go full screen with the slides?
Sure. Like this?
Yeah, cool.
Yeah, gRPC, the RPC has been around for a long time. It's actually funny how it never got really any decent traction. I remember when I started off with Java long ago, 20 years, I think. I still remember the RPC stuff, and I think I even used it, but it never got. And it wasn't that bad as far as I can recall, but just never stuck around for it, right? gRPC, then probably have to remember what's the real benefit of gRPC over RPC. I guess probably the ease of use. The gRPC probably they did learn a thing or two from the RPC. So gRPC, I guess that G stands for Google, pretty much, I think so. You can have it has coverage in all sorts of languages: Java, Go, Python, C++, and so on. At the end, as I'll have it in the next slide, at the end, it's like a description of your services and your messages between those services. It's like in a files called protofiles. They have the suffix .proto, right, from the and it's the protobuffers. It's a library from Google as well, that handles how you can easily create compact messages, which can also stand the test of time. So if you somehow change the message format and so on, if you do it properly, like the right way with protobufs, you can easily have the legacy messages and the new messages, and they can still mix and match, right? So you don't have to. It's like a numbering of fields inside those messages, and you somehow just increase the index of or number of that field, and it should work, right? So that's the beauty of it. And then this proto compiler creates those out of those proto files. It creates those. It defines it creates the services, the stubs, so that most of the transformation between communication underlying communication is done by those generated stubs. And similar it's like the base implementations of the services and stubs for the clients, right? So that means you get these idiomatic clients and service stubs for free, just out of the box. the clients can be used immediately, where the server stubs, of course, they only handle the actual transformation, the underlying communication, where of course they don't have the actual service implementation, and that's up to you. So you need to somehow, they make it in such a way that those are abstract methods, and if you don't have to actually implement them all if you don't want to, but if it's going to get called, it's going to be like unsupported or undefined method, right? But how you implement them, you just override them and with the right implementation. As I already mentioned, it's really nice that you have bi-directional streaming. You can either stream, you have a on the client side, and that's all transparent, right? That's the beauty of it. You don't have to somehow open the connection, close the connection, do anything special. Just have this streaming observer, which you can just, like with the new reactive notion or like a new ideology that we have, is like you just push things into stream, and you somehow need to, of course, you need to, on the other side, you need to take them out slowly. And I mean, I remember this is how I came up really a bit closer with gRPCs when I was working on Streamzy team with Kafka and Kafka Streams. And Kafka Streams have those Kafka Streams stores. They only have it in memory. And the moment you somehow want to have a distributed Kafka Streams store, you need to have your own implementation of that store in place if you want to somehow have it distributed. And I found a really nice solution on top of gRPC. I mean, I wrote it myself. I was like thinking, I need to have streaming because Kafka stores know how to stream all the values from the store, just filtering some of those and so on. And this is exactly how, like, it was really nice how gRPC went about with this streaming support. On the other hand, it also has there's like pluggable load balancing, when you can somehow set your own load balancing. This is what we also use, take advantage of in Quarkus. Tracing is already integrated somehow into it. Authentication and authorization can be tied into it as well, and so on. So it's like a library that's been around a while, and you can tell it's been around for a while. That's the example of, really, really trivial example of the proto file, right? You can somehow describe this one is meant, of course, for Java. So at the end, the proto C compiler, which I think it can handle all sorts of it. And this is how the instructions of what to create out of it. If it wouldn't be this Java multiple files, we would probably, I don't know, Python or Go, it would create Go stubs and services and so on. In this case, since Quarkus is about Java, it's like an example for Java. It's really, really trivial, right? But this is how it is. Like at the end, you don't have to do much. And that's probably the beauty of it. You can split your services and your messages into multiple files, or like a single big file, and then have these package names or joined like a single big class, and have those services in a single class or a single implementation and so on. So it's configurable, and it depends up on the user what way it prefers.
Nice. So in this example, would the typical pattern be that the top part be in one file and then the Java part would be in a different file, or do they sort of end up in the same file?
What I mean, it's like in this case, I think everything will end up in a single file.
Single file.
Yeah, until it'd be like in this case it would be HLWV, right? And it will be the services, abstract classes in it, and the client stubs as well. But you can split them into separate classes and different packages and so on. So yeah, but I think all the definitions then share the same configuration, right? A single file has this single configuration on the top, right? Yeah. Okay.
Cool.
Yeah. Okay. So, like I said, with HTTP being really RESTful services being really simple to use, that was our goal as well when we did it. So I know the title was called "What's New in gRPC." We'll get to that. Not as much new that you would see like it, because there's not so many features that we could just call it like it's really super new. But yeah, right, it's still just to explain what we do. Like I said, with the RESTful, it's easy, just annotate, and this is what we want to do as well. At the end, you just have this, like I said, you have this service. Okay, I forgot. Yeah, okay, could be. We actually, we have this Proto-C compiler. What we do is it can actually be extended, so you can pass it on your own code generating template or code generating mechanism, and this is what we do. So instead of gRPC, still, I mean, being nice as it is, it still goes about actual classes, actual abstract classes, or concrete stubs for clients and so on. Whereas you're pretty much used to using interfaces now, right? Interfaces is like the interface is the way to go to either like your client should be an interface, your service must implement an interface, so you have like a certain signature that you can then easily share about, instead of sending like, oh, this is my service, like a giant stub, which plenty of the code doesn't really concern me, right? Whereas I can easily send you, oh, Holly, here's an interface, and you would immediately know what I'm talking about, right?
Yeah.
If I send you the stub, you'll have to, and then I'll have to explain, just get rid of all those methods, intermediate methods that somehow help transform things in a proper way. Just have a look at the actual methods, the signatures of the methods that I wanted you to implement, or I wanted you for the client to be exposed, right? So, and what we did is we added a way to create interfaces for those services described in the proto files.
Nice.
That's like an extension that Quarkus provides. Like being super reactive fans as we are, right? We and gRPC being the idea of it being pretty much reactive or non-blocking, right? We went in the direction of having it so that interfaces are actually a mutiny interfaces. I guess being the Quarkus Insights people, you already did talk about the mutiny, like a reactive library done by Red Hat, which is pretty much used a lot in Quarkus itself. It provides like a really nice, sort of complex implementation of the reactive idea, right? So, and that's how, like in this case, if you look at the slides, the greeter itself would be a somehow mutiny-backed interface. To return back to the simplicity of it, so just say class greeter imp extends greeter, and I would implement the services, adding a notation on top of it, gRPC service, and I'm done. So Quarkus would pick it up and it would install this service into the gRPC server, expose it as a bean. I get all the beauty of CDI, injections, configuration lookups, and so on. So all the benefits of CDI. Similar with the client, I can just say, I don't even have to say inject me greeter client. I still need to, for the sake of configuration, I need to annotate it with gRPC client annotation. Simple inject, I guess we could do it, but at least still be a bit more explicit. And adding another annotation, I don't think it's as verbose, right? So, and you get add gRPC client, greeter client, and you get the full client nicely injected with all the configuration, and you can then do gRPC calls on top of it. If you need to add some interceptors, since these are already, at least the services, of course, are beans, you can use plain CDI interceptors if you want, right? Because at the end, it is a bean. But if you want some more gRPC specific interceptors, which gRPC provides, you can annotate your interceptor implementations with either as like a global interceptor. It will be applied, and it will be applied to all the gRPC services, all your gRPC services, or you can register a per client or per service interceptor. And then, of course, you add this add register interceptor on top of like greater implementation class, and you just apply that interceptor that's provided in the register interceptor annotation. Or, I mean, if you're still like an old school gRPC user, you can use any of the stubs, either streaming, blocking, future stubs that are generated by default Proto-C compiler. That's in a nutshell, right? That's like really easy. But of course, there's quite some magic behind it, quite some code that makes this simply like this add gRPC service and add gRPC client work.
I mean, that's the best way, isn't it? That like on the surface, it looks really easy. And if anybody knows, you know, the REST client and that kind of thing, it's going to be super familiar. But then under the covers, the Quarkus team are like, you know, the duck under the water, sort of paddling a lot to make it happen.
What's happening? Where am I? I need to go back. How do I go back? Just close it, and then I'll go back. And I'll go like this. Okay, so this is like the overview of the project, how we somehow split all the magic code between the project. As everything, it's of course an extension, as everything else, like the core of Quarkus, just handling all sorts of extensions for even like the most basic like stuff for like web servers and CDI and so on. gRPC is no different. It's an extension. Like we know, we split the extensions into runtime and deployment, where the runtimes hold this cool feature of recorders and substitutions for the native compilation if needed. In this case, we do need a couple of substitutions for things to work up nicely. Some of the stuff is, I mean, being, like I said, being an old school library, it does have still things that we need to substitute for order to make it work. We have different server implementations. We'll get to that in the next slide. That's the cool and new thing, probably since the last time somebody spoke about gRPC and the insights. We have a couple of default, nice, useful interceptors that make users' life a lot easier. Instead of, if you go with Quarkus and gRPC, instead of doing it on your own, I mean, you can always just easily have generated things and then create your own beans with implementations and so on. And you wouldn't even need to use gRPC, right, in order to make it work, Quarkus gRPC. But if you go with the extension, you already get most of the benefits and things that we carefully thought about in the sense of interceptors, in the sense of how servers can be configured and so on. Okay, deployment. This is where the processors, where we process users' code, create build steps and items in order for the extension to work. I already mentioned the API. It's the gRPC service, gRPC client. At the end, it boils down to really simple things, mostly annotations, as like I said, the REST full usage was our goal, pretty much making it as simple or copying the features and so on. As I already mentioned, the Proto-C, we have our custom generator extending it. And we create a bunch of Mutiny interfaces and stubs. It's like a mustache templates. That's the library that's used underneath, and it produces source code, which is then compiled normally as every produced source code inside the plugins, either Maven plugin or Gradle plugin. The beauty of it, again, is not just this custom gRPC generation. The thing is, I remember being like user of gRPC before there was Quarkus. I always remember having to look it up how I use. I mean, I did it like the first time. It was like a nightmare to set up the whole protobuf, proto-C Maven plugin and have it done correctly. There was like some extension needed to provide underlying operating system, so it knew which executable to pull down and run and so on. With this, it was like with Quarkus, you don't need to add any of it because it's the Quarkus Gradle plugin that does all the heavy lifting, and it hides this inside the internals of it. Quarkus has like a generic code generating mechanism, and gRPC is just one of it. There was another one. I can look it up later on, but so it's like that's tied into the Quarkus plugin, either like I said, Maven or Gradle, and it runs. You just need to add a goal generate code or something like that, right? And if the right extension with code generator is on the class path, it will be picked up and it will be run as part of the plugins process, like part of plugins goals, right? So no more painfully looking up how to set up the protobuf or proto-C Maven plugin. And then we have some stubs module, which is where, of course, at the end of the day, we didn't want to, do all this was already done and do it from scratch, like reinvent the wheel. Just like a code that somehow goes from the mutiny generated stubs that we generate, and then we somehow reuse the code that was generated from before. Because I mean, we know there's like a history of working projects on top of those gRPC stubs and services. Why should we, create our own stuff as we can easily just reuse that since we know it's working properly, right? So we have some code that transforms between plain gRPC code and mutiny. Some, server calls, client calls, from server, from stream observer into uni or multi or vice versa, right? From the mutiny library. Next. Like this. Okay, that's what I mentioned. The servers that we implement them in the runtime. We started off when initially there was like a gRPC support, and this is probably when there was the last time we spoke about gRPC here. It was the old Vertex already had an extension of the existing netty gRPC, and just added a bit of things on top of it to make it a bit more extendable, at least somehow reusing some of the Vertex code already. But what that meant was that, of course, you had to start your own new server. So in the case of you were running a web server on 8080, but then you had to start another server on, this case, on the 9000 port. With everything had to be redone, all the security configuration, certificates, etc., timeouts, and so on, right? Duplicating the configuration. I mean, it wasn't the worst, but it wasn't, really, right? You already did it once, and I don't need to do it again.
Yeah, plus, it doesn't seem so efficient.
Yeah. Plus, for us, I mean, we had to do it. We had to have duplicate configuration, one for Vertex Web and one for Vertex gRPC server. So there's an ongoing debate, and at one point, it was decided there's going to be a new Vertex gRPC implementations, which are going to be tied directly into the existing HTTP server. That's the beauty of it. So we know by default we are still we still go with the old one, which was a bit more proven, and it has a bit more features we were somehow lacking behind. But the new one, we do somehow issue a warning, like you're still using the old one, which starts a new server. Consider trying a new one, which doesn't start a new server, right? So the new Vertex gRPC ties into existing HTTP server, and you get all the benefits. How you configure your existing web server, this is how gRPC is going to behave as well, right? No more duplicate ports and so on. Then later on, the library, the gRPC Java library added, I don't know when did they add this. It shouldn't, probably it's not too old because it's I think it looks like relatively new. It's something called XDS. The X actually stands for, like in the case of the slides, like a star. It's like it stands for everything. It's like any kind of discovery service, either a failover service, lookup service, and so on. And it's like a generic spec, and gRPC just implements it and uses it. So instead of you having to do, in the case of, if we're speaking about gRPC, it's you doing, having to add layers in front of it to somehow do the load balancing or failover or service discovery. It's the XDS spec or I don't know, protocol or platform that does it for you, right? Somehow there's like a XDS server in between, which when your XDS services and clients connect to it, and they somehow get notified about how the environment, or how does the whole service platform look like for them. If some new services connect, they're notified, and then the clients can, there's like a new service coming in. XDS tell me which one I can connect to, and then probably just tells it direct, and it connects directly. So it's like an idea of somehow the proxyless gRPC, right? No need for the proxies, since you have this at the end. At the end, it is like a XDS proxy or like server. The thing is, it's still like in the early stages, as far as I can tell from the documentation that's out there, and this is going to be a subject of the demo. At least it was like me battling with the documentation and looking what it needs to be added at the end, and there's like finding a needle in the haystack at the end. A couple of annotations that needed to be added to Kubernetes deployment in order for everything to work, and that's in the demo, so I'll point it out what it is. But yeah, it's like a new feature. I wouldn't say this is probably going to be the first one that you're going to use. I guess you really need to be familiar with what the XDS does and how to make it work. In the case of what I was using for the XDS, Istio is an XDS implementation, so I'm using Istio. I guess it's like Istio and Envoy in the back or something like that. So yeah, I'd say like this is a really, really advanced use case, but at least I'll show it in my demo, and you have a thing that's working, at least to see what all I needed to add for it to work. But then you can probably try to discover a bit more on your own. Another one was the in-process.
Oh, sorry, before you go on, Aleš, we've got a question about whether now it's merged with the HTTP server, if people want to customize the gRPC config differently than HTTP, is that possible?
Oh yeah, okay, see the question. Different. No, fortunately, I mean, depending like the HTTP, at the end, gRPC is nothing more, right, than the HTTP2, like an update or upgrade, or how you call it, right? So unfortunately, I mean, you're stuck with how you configure your web server or HTTP server. But you can always, I mean, if you really need it differently, you can always fall back, or currently you need to upgrade for the new one, you can still stick with the old one. where you create, but then you're still up with 2 different servers, like the gRPC server and the HTTP server. Most cases, people still probably prefer the new way, right? Where you don't have to configure 2 different servers with all the configuration, and then making sure that both of them are up to date and you don't miss one of them, right? And then behaves differently when you pass somebody to, this is the certificates. But if you really have the need to go with a different one, then you can fall back to the old one, and everything should work. It's not going to go away anytime soon, right? We're still support it. We still add new features to all of them. I mean, I just called it old because it's the first one. I mean, probably I could probably call it like the first one and the second one. There might be a third one, I don't know. But yeah, that's probably the way to go. I don't see it any other way, right?
Yeah, I guess another thing that you could do, but it still involves having 2 servers, is you could have both on the latest level, but you just have one configured in one way that's handling most of your gRPC traffic, and another one configured a different way for the HTTP traffic. But then you have to have an inter-process communication. And then you say, hey, what shall we use for our inter-process communication? What about something like gRPC? And then you end up on a bit of a chicken and egg situation. So we've got a follow-up as well of.
I mean, I don't see like the fallback. It's all. I mean, at one point we added a new Vertex implementation, and previous ones, of course, didn't have it. So we added a new one, and from then on you have both, and there's like just a configuration switch on which one to use. Unfortunately, you can just use one. It doesn't make really sense that it will two. In the worst case, what you can do is then you probably, as Holly mentioned, if you want to use some of them, want to have them in a new HTTP way, and some of them in the old like direct gRPC way. Probably have to split the services into different microservices, right? And then it can only be just like one, right? Either the old or the new.
Do you happen to remember the name of the config property? And I'll paste it into the chat if you do. If not, I'll look it up.
Well, I mean, let me just. I'll find it.
It's the bit that you sort of didn't think to prepare for of a detailed quiz on Vertex configuration options. Cool. I'll paste that in.
Yes. So, and there's also like a 4th version of the server type. Like we already had like the old, the new, the XDS, which is really advanced. And there's like an interesting. I mean, I guess I probably should follow more closely the landscape of the gRPC, because I mean they're adding these things, and we were somehow pinged by a user saying like, why don't you also, guys, since you made it now easy to support old, new XDS and so on, as I made at one point, I created an abstraction between the services and the clients. I mean, at the end, it's like a channel that does the work on top of with the client stubs. And there was like there's like an in-process thing. Oh, what's this? And it's probably, the name serves it really well. It's like an indirect, there's no need for the connection. It's like an in-memory invocation, right? Which really makes sense for the testing. I mean, of course, doesn't make any sense for productions because it's like a just in JVM thingy, right? No connection, and it's really fast for the services. if you have lots of services where you just want to somehow test if your services work correctly, if your, are they following the spec? Are they following the API? Are they following the signature or the contract that you wanted to have in between services? And I remember I was like, oh yeah, that's cool, but yeah, well, I can still. And then there was like a user that had lots of services, right? And I guess if you wanted to test those and to have a connection spinning up a server, adding a few services, a connection to it, and so on, if you sum it up, it will take forever. But with just marking it, oh, I'll use the in-process stuff, it will probably be super fast, right? We're talking about thousands of services, and just having to test them, just use in-process. Again, it's I'll quickly show it at the like a different demo a bit. Just it's like a flag, or a switch you turn on, and it goes into in-process server type. And
yeah, that makes so much sense. Like, because we sometimes have that even when we're just doing like a demo of microservices, and you end up having to tab between all of these windows in order to show the microservices, and it's annoying. And then when we're trying to test them, even just to get like the sort of the surrounding infrastructure to spin things up and get all the different processes and manage them is a little bit annoying if you're just trying to test your protocol.
yeah, I probably you know it best, right? You're doing the contract testing and so on. In this case, this is ideal, right? Instead of having to spin up a server, create a channel, open the channel, close the channel, to test it, and so on, they're still as fast as it is. It's never going to be as fast as in memory, right? This is just like it's like a call directly to some static instances, some static code that it's in memory, and just directly accesses it through probably static handles, and just calls up a service on top of it, right? No connection, no nothing. And everything, the whole idea behind the server is probably just properly setting up some maps of services, and that's it. And transforming the calls into the routing them to the in-memory services that are held in memory, and that's it. Okay, a bit more, like I mentioned, we can probably skip this. It's like a mutiny, cool, but complex Reactive library. Once you get your hand around it, it does all sorts of things. And this is what you use, like I already mentioned. We generate this basic information like the stub. In this case, of course, there's no blocking implementation, because that is the purpose of mutiny. It's non-blocking. And as I mentioned, there's no stream observer. You get to work with uni or multi instead. Features, I mentioned all this already. Oh yeah, then if you have, I think by default, we do the non-blocking. So we expect the methods to be non-blocking. And if they take a lot of time, it's like the vertex checker that kicks in and somehow warns you, you're taking too long. And if you have something like this, or in some cases, probably we'd even fail. I don't know, just saw recently with JPA, you can fail. With other things that are blocking, you can fail. If you have this, we'll already support this at blocking or non-blocking annotation, and it will move it either from working thread to from event loop to working thread and something like that, or vice versa, right? And just that's really new, hot from the oven, is the run on virtual thread. This is just something Clement just previous week, or it was like even during the weekend that he merged into it. Fortunately, I think not yet. I think we missed the 3.22, and I'm not sure. But it will be next. It will be in the next release of Quarkus, and you can just enter. And if your JVM supports it, you can annotate it, run on virtual thread, and it will run on virtual thread. Right? Cool. For the dev mode, we get this hot replacement, as probably with most things that we do in Quarkus. So we do have this hot replacement handle, which somehow constantly checks if there's something new, and we somehow mark which. This is like the overall feature of the dev mode is it somehow tracks which classes are tied to certain classes, and if you change something, it will just hot redeploy those, and we know how to handle. At least with the old one, with the new one, it's a bit. We just throw away the whole route handler and create a new one because it's so cheap that it didn't make sense for us to implement it the old way. The old way, the server stuck around, and we just cleaned up some of the bits and pieces, the internals of it, and replaced it with the hotly redeployed things. With the new Vertex, we just throw away and create a new handle because it's so cheap to create it. XDS and in process. That's a different thing. The XDS, especially, it's like too complex to actually think of it as a hot replacement. The in-process thing is probably the same way as the new Vertex. It's already in memory and it's cheap to just throw it away and create a new one. You get health endpoints out of the box as well. Either how to say, I mean, both things like is it running, like the liveness and health and readiness, right? You get them both. In this case, they're gRPC implemented, right? But if you add the small right stuff, you also get other endpoints as well out of the box if you really need it. We added previously just like a authentication exception handler provider. In the case if authentication failed, you're able to provide your own mechanism in what to do with it. And then we expanded this into a overall exception handler. Because in the case of gRPC, at the end, you always somehow get a status exception, status runtime exception, or status exception is a checked exception. And then what you do, this is what it boils down at the end on the client side, right? And you need to somehow, the beauty of it is that you can map your server-side exceptions to those status exceptions. And this is what it does. Like by default, we do it as previously. We use the existing mechanisms of the gRPC, but now you can do it even like custom instead of, if you have some custom exceptions, you can customly transform into your own status exceptions by your implementation. Right.
Nice. So we've got a follow-up question about the HTTP and the config, but also about authentication. Which is, if we use the new version, is there any chance that we could indicate for HTTP authentication that for HTTP authentication is required, but not for gRPC? Because normally they'd have HTTP to outside and gRPC for internal.
Oh yeah, okay, I can see what you mean. Oh yeah, that's probably more of a question for overall Vertex and HTTP, right? I'm not really as super familiar what you can do on the HTTP side or the Vertex website, how you can configure for those. I guess, I mean, okay, I guess you can, there's like a route thing that you could probably set up overall, I guess, with the certificates and all that stuff. I guess that probably won't work because it's either all or nothing, right? If you have the TLS for more, yeah, I guess check it out. I mean, probably,
Yeah, I feel like it is possible, but I wouldn't want to say what the mechanism
don't hold me
is.
for it, right?
Yeah. So it might be one, unless someone else on the chat knows the answer. That might be a good one to ask either on the Quarkus Zulip, the user stream on Zulip, or on Stack Overflow, because the Quarkus team do monitor that as well.
Yeah, I think, yeah, okay. Let's go. Okay, so as I mentioned, we have this load balancing and name resolving and failover. The old one has this like really nice, and the thing is like the old one is probably long, it's long enough around that it had this feature request, and at one point they added this. So it's really nice, and you can directly extend this to the API. It has this like a SPI API thing internally, which you can use or abuse. And we added this Stork. Stork is a small Red Hat library for all these mentioned things, load balancing, name resolving, and so on. With the new one, we did add this load balancing and failover to some extent, like with a custom Stork channel. It's not ideal, but at least we did move, like the feature is supported to some extent, but I mean, it's not the best. So, I mean, not the best in the sense of that we see this as a lacking feature in Vertex in general. So there's like a generic or general Vertex solution in the making. I need to check how far we actually got with that, the Julian. But yeah, it will be more nicely integrated eventually, but currently you still have this Stork support in both integrations. Another thing is what we also provide is like a reflection service out of the box, which is like a feature of gRPC. You have this, I would say, like if you add this service into it, you get this custom, you have these known calls that you can make in order to list the services, get file descriptors for the service, etc., and so on. I think we add this reflection service by default, but you can disable it with a flag and just say a reflection service false or something like that. For security, we do tie with Quarkus security as well to somehow with your own custom gRPC security mechanism, which is then tied and used if we find a gRPC security mechanism implementation on the class path, we will add soon enough in the chain of interceptors, like a global interceptors on the server side, right? Which will kick in, and it will try to set up a Quarkus security identity for you out of the gRPC invocation information, out of either metadata or some other stuff, right? Proto usage, I already remember that. There's no need for Proto plugin, really good. And there's a bit more to it. We can also configure all sorts of, check out these external imports when you're generating the Proto, filter out dependencies, add certain dependencies. In the case of, for example, if you just wanna you're using an external Proto, like a huge one, probably from, some existing cool service, but you only need like 10% of it. Otherwise, it's gonna get really huge, and it will generate you a bunch of classes and stubs you really don't need, and it will blow up your application. Where in the case where actually you just need, 2 services or not necessarily, you need a couple of messages that you want to send because of like a known message types that you need to send, to some server, and you don't want to copy paste it, you just want to use then you can filter it out. So that's the way as well. The idea, like, this is really, really far off, and it's still a work in progress. Probably just at the state of being an idea and nothing more. Is, like we said, like instead of going from proto files, right, we go the other way around. We go from interfaces, and then we create you everything else. Proto files which you can share, because there's like the old way of sharing proto configuration generation, right? But you would go from interface to create your proto file, and not the other way around as it is now.
What would the Do you think we'd be able to do that and keep that characteristic of having compatibility between the versions?
Yeah, that's a good question. Yeah, I think it depends how much. I mean, yeah, okay, if you just generate, as it is currently, right? You have, if you saw this like in the proto file, you somehow marked it, this is proto number 3, right? And some of the, and then I think it's the proto CS itself that somehow knows, okay, oh, you're using a proto 2 feature which won't work with this one and vice versa. And so it's like it does know how to compare a couple of things, right? And probably this would boil down to the same case with this new stuff, right? When you can go from interface to proto and we'll say, okay, this is like proto 4 or proto 5, I don't know when it will be up. I'll just say, yeah, okay. I remember using it quite long, just say, okay, you're using a proto 3 feature with, I don't know, with something that's proto 2 or something like that. So yeah, it's always the issue with versioning, right? It's not like a easy solution for any time that versioning comes in the play.
Yeah, and then what I often see is that people then say, "Oh, this solution's really hard," and it's like, no, it's not. The problem isn't the solution. The problem is that versioning is really hard. Just full stop.
Yeah. Okay, then let's. Yeah, this is if you want to somehow. Oh yeah, it will be there. This is like my sandbox repository for all sorts of things, from issues reproducers to to me playing with gRPC, XDS, and so on. So let me just, and then I'll stop sharing this. And
We're gonna have to do a fast demo as well because we've
Oh,
kept you
yeah,
talking.
yeah. Oh yeah. We're stuck in. Let me just this one. Okay, I need to
Cool.
go.
We have a terminal.
Yeah, I'll just stop. I need to share something else first so that this. I'll be really quick. So this is not the. Do we see it?
Yeah.
Oh yeah, I already made it bigger. So this is just the logging. So, but this is how you enable the XDS, telling it I'm using the XDS. Plus, this is, I mean, at the end, I did split it up. So it's like it doesn't populate or pollute the the plain Quarkus gRPC extension. It's like in a separate artifact, but this one extends. I mean, this one depends on the general gRPC extension, so it's good. And yeah, this is how you enable it. Tell it, okay, enable true, because you still want to enable it, explicitly enable it. You set up the port. In the case of client, you enable it by telling the name resolver is going to be XDS. And then, of course, you need to tell it where to find the services and the port which matches this one. And then the beauty, this was the needle in the haystack that I was talking about. So this is what you need to add. Okay, not this one. This one, this is just I'm deploying to Minikube, and this is the port that I'm exposing. But this is the feature, because with this one, it didn't work for me. And I was looking, and finally somewhere in the documentation, this was somehow like slightly mentioned. And I said, okay, I'll go with this one. I'll try it and see what it does. And it made it work. This is one thing that I want to show. And and I'm gonna deploy this to Kubernetes, like to Minikube. I'm sort of like, I'm mixing and matching properties, and probably Holly can tell you more what's the good way or how to do it. I can easily have those properties, the annotation properties here, or I can go the other way around. I could move these POM XML properties out of here and move them into the application properties, right? I don't know. I mean, like, what's the best way to do it. I guess it depends on how you see what needs to go where, and then you do it the way you see it, right? Or it could be like Quarkus having a unified single place of configuration application properties. Probably could be better to move this out of POM XML into the application properties. I don't know. So that will just stop sharing, and I'll just do a simple run. You'll see how it should be. This is like Maven clean package. I'll skip the test. I actually have a few tests. And then minus p gib. So it will generate, with gib, it will generate me a Docker image, which it will deploy into my mini app, mini tube that's already up and running. I already deployed Istio into it. Okay, it's running. They're deploying to mini cube server, blah, blah, blah. And the code, I mean, what it does, it starts up a service, and it's actually like another, it's like a really stupid demo actually, but it's like a query that adds a bean, like a scheduler bean that gets client injected into it, and through the via client, it calls the service itself. It's all in the same application, right? Yeah, but just for simplicity's sake, let me see the pods. Okay, we get this pod. Let me just copy it. And it said like, okay, I found blah blah, bunch of XDS things right inside.
I think you might need to share another part of your screen.
Really? How does it look like? Oh yeah, okay, it's 8 up. It's like cut it down, but oh no, yeah. I guess. Oh nah, wrong stuff, right? I thought the terminal was all in one, right? This, yeah, okay, sure. Yeah, okay. Yeah, you can see that it started off, it started gRPC,
Cool.
the enabled, then it targeted the client stuff for the XDS. So it told the XDS, I'm this client, let me know. And then the XDS server routed the client to the service. Yeah.
That is cool.
Yeah. So yeah, I can stop sharing. So yeah, that's mostly it, right?
Cool. And you managed to do that demo in
Yeah, really.
almost no time at all, which is
Yeah.
awesome. Yeah, and that is a cool demo. Is the I was about to ask if the source code for the demo was available, but then I realized you already shared it.
Yeah.
So we're good on that. And I think so. We've had lots of questions as we've gone through. If anybody has any other questions, now is the time to ask before we sign off. But that was really interesting, and
Yeah.
and it's so nice to see that we're adding that Quarkus magic and that Quarkus joy and making something easier to use and more
Yeah, it
familiar.
probably would take me a bit less time to explain it, but I actually got surprised myself that it took me so long.
Yeah, cool. Well, I think we can sign off then. So thank you, Aleš, and thank you everybody for the questions and the comments.
Yeah, thanks.
See you all.
Bye bye.